All right, good afternoon, everyone. I am your host for today's webinar. My name is Dan Struble. I am hosting this webinar, and we're going to bring a guest speaker in to kind of go over some interesting things that come to customizing your SINUMERIK control. I'm going to kind of get into kind of some of the things about our team, who we are, where we are in our team as we go through this webinar, and how you can kind of find some of these things and trainings and everything as we move in. And then I'll introduce our guest speaker for today, who is Brian Baumgartner. He comes with a wealth of knowledge. He is going to be giving the content on how to use this thing called MMC. It's a very cool thing on our SINUMERIK control, and I think that everyone's going to enjoy it. So let's get into it. So who are we and who do we belong to? Well, we're part of this team called Technical Application Team here at Siemens. Our job here is to kind of take the technology from SINUMERIK and show everyone how to use it. So things like the MMC command and things like how do we use our control to its fullest capability. And these are one of those ways. We have a few people on our team. We have myself. I sit in Illinois at the DEX. DEX is a facility where we actually have some machines and we do trainings there and everything. And then we have Brian, who's in New York, as well as Chris. And we have Rich down in the Carolinas. So we have kind of a team, and all our team has different specialities that we can kind of go through and show you our expertise on different topics for the technical part of SINUMERIK. A couple of things that our team does is we do CNC trainings. You can find it at usasiemens.com, CNC training. We have a program called um, VTAC, which is our virtual TAC, which we have at Chris's facility. And this is something that we kind of go through videos, and we show our videos on our YouTube channel, kind of going through some how-tos and some past webinars. This webinar is actually going to be uploaded to it afterwards. And then we have direct customer engagement with our VPE program. And you can go there to a VPE session, sign up for it, and within 24 hours, we'll give you some type of feedback to a meeting or to an expert that can answer your question. This is one of the programs that actually our guest speaker is actually the manager of, so it'll be nice. Content Manager, this is a nice thing that you can download off our CNC for You website. We actually have categorized all the videos that are on our YouTube channel that give you everything that you want to know. So you can kind of filter for it. Like you're a beginner, you're advanced, you want to learn about milling, you want to learn about turning. It will kind of filter out all the videos that we have on our YouTube channel. So you can kind of click through those and kind of get informed on SINUMERIK control. If you watched every video on our YouTube channel, you would become a SINUMERIK guru. One of the things that I would say that it would be my greatest honor for everyone on the webinar to just show awareness and get people to join our contact list. The more people that we have on our contact list, the more people that we can stay in touch with, and we can actually help them kind of get to these webinars, get the trainings, understand what we're doing from day to day. And then a couple things that you can kind of find us on. You can find us in YouTube. We also started a new channel, Mr. CNC Insights. That's a channel that Brian Baumgartner spun up this past year to start going after things that are kind of service-oriented topics. It's really nice. You can find us on Facebook as well as on Twitter. So who am I? I'm Dan Struble. I'm the Technical Application Center Manager here at Elk Grove, and I'm going to introduce Brian Baumgartner here, and he's going to take it over from here and start sharing his screen and kind of get you into the MMC command. One thing I'll say though, before I hand it off to Brian, is I'm going to be monitoring the chat and questions. So as we're starting to talk and as Brian's starting to talk throughout the webinar, please get in the chat, ask your question, go to the question section, ask your question. So that we can kind of have those for the end of it so that there's not like a mad rush on the chat. So throughout the webinar, I'm going to be moderating the chat and writing these questions down. So if you have anything to start out with, put it in chat or anything from that. But without further ado, I will introduce Brian. Well, here comes Brian with his content.
Awesome. Thank you very much for the introduction, Dan. And also thank you for promoting the VPE program. I hope that everybody does find that useful. Do feel free to go to the website and submit your requests. I look forward to assisting you there. But today, we're here to talk about customizing pop-up screens with the SINUMERIK MMC instruction. So I'm going to get started with our presentation. We have a great agenda coming up for today. First, we're going to talk about the MMC instruction itself, because some of us may not be familiar with what it is or how we use it. And then we're going to put things in a different order. So normally, when I've done webinars in the past, I go through the theory and then I show you the theory in practice. But I think this time it's going to make a lot more sense if we dive right into the demonstration first and we see what kinds of things you can do with the MMC instruction. Then after that, we'll take a look at how we did them by analyzing the code that was used in the demonstration. Once we get done analyzing the code, we'll look at troubleshooting methods. And then in some cases, and in some cases not, there is a requirement for a Run MyScreens license. So we'll look at that as well and see what we can do there. So moving forward, what is the MMC instruction? So the first thing to know is that MMC stands for man-machine communication. And this is an instruction that's going to be invoked by the part programmer to do two things. One, to open our dialogues, which we also call pop-ups, but also to close the pop-ups. Now, the dialogues can not only be used to display information, but they could also be used to request machine operator input. So that input can be used in the part program to make decisions of how the part program is going to execute. Finally, the functionality and the format of the dialogues that's called from this part program instruction is going to be defined in uncompiled text files, and it's going to follow the syntax described in the Run MyScreens programming manual. We're going to take a look at the programming manual later on in the webinar and see how those uncompiled text files are built up from scratch. Now, you may be curious to know, does your system support the MMC instruction? If you're using SINUMERIK Operate, the answer is almost certainly yes. If we look back at the 828 control and look through all the part programming manuals that we have, I started seeing this MMC instruction come up around version 2.6. With SINUMERIK 840, I saw it come up in the 1.5 documentation, and it's existed for the whole life cycle of the SINUMERIK 1 so far. However, today we're going to look at the extended configuration syntax, which I personally think makes a lot more sense than the base functionality. With the extended configuration syntax, we're able to use identifiers for each of the arguments that help us to understand their significance. So maintaining the code and even developing it for the first time is going to be a little bit easier using that syntax. Now, that one was available starting at version 4.7 on the 828 as well as on the 840, and then it's been available since the birth of the SINUMERIK 1 control. Before we get into it, I want to take a look at a typical application requirement. So this is something that a lot of us have to do. Imagine we have a part that's gone through some kind of first operation already, and we have to do a second operation on top of it. Well, we need to know where that part is sitting in space. So we want to find the work offset. In this example, we have an inclined plane, and we need to find the center of it, as well as the angular offsets in our A, B, and C axes, rotating around the X, Y, and Z. But after we find the offset, we want to know, is it within tolerance? Because maybe in this example, we didn't drive the car into the machine in the right angle. So if it's off by too much, we might want to go reposition the part, for example, and then do the work offset measurement process again. And the last thing in this sort of typical application is that we would run our secondary operation. And in the application you'll see today, that operation is going to be engraving. So given this application, there are some design considerations that we have to think about. Number one, how can we visualize probe results in an intuitive and operator-friendly format? Number two, how can we enable decision-making with options to both accept and reject the results? Number three, how can we request operator input to be used in a part program via the graphic user interface? And finally, how do we do all this to streamline our machine processes using the customized dialogues, but most importantly, without modifying the core system software? So we don't want to introduce new functionality that makes our existing functionality not work, right? So if this is our design consideration and this is our application, then the MMC instruction could be a very good solution. What you're looking at here are 3 snippets from the application that we're going to dive into momentarily. But before we look at the application, I want to show you a flow chart of exactly what we're doing. So here we're going to start up at the top in this green oval, and we're going to proceed all the way down to the end in this red oval. Every time that we see a blue diamond, we're going to be making a decision. It's either going to be a yes or no decision. And as we go through the flow chart, when we see boxes, we're performing an operation. So here at the beginning, as long as we're following the green track, we're saying yes to all the prompts. If we ever say no, we get on the red track. And in this case, the red track is usually going to take us back to a spot in the part program that's going to send the machine home and then go to the end. So for example, at the beginning, we'll be prompted, do we want to measure the work offset or not? Well, if we have not qualified the work offset yet, then we're going to pick yes, and it'll automatically come in to run a plane aligned cycle. Then once the cycle is complete, we'll see the results and we'll either be able to accept them or reject them. And if we accept, we'll continue on this path all the way until we get to the prompt here, indicating whether we want to engrave the text or not. Now, if we have already qualified the work offset, then we can skip that step and go straight to engraving text. All right, so now that we have an understanding of how this application is going to work, let's take a look at it. There we are. So here I have a high rail 5-axis mill and create my virtual machine. And I've got a truck loaded right there on my bed. And what I want to do is run this program that's been created for the webinar, MMC Custom. Now, let me show you how that program is written. So first, I'll go into my program manager and open the program. And what you can see, if you have good enough vision, because the text is a little small, is that the program has been grouped into different units. So at the beginning, we have our measurement cycle preparation. Then we start with all those operations we saw in the flow chart, align the plane, find the Z surface, and onward until we get to engraving. And finally, there's an error handler at the end. We're going to look at some of these later on, but for now, we're just going to continue and execute the program, which is already loaded. So here, once I push cycle start, I'm immediately prompted with a custom dialog here that says, please select operation. One thing you can do with these MMC dialogs is that you can add custom buttons if you wish to. So in this case, I can either push work offset measurement to begin the work offset measurement cycle or engraving. So I'm going to push work offset measurement and the machine's going to take off and begin the first operation. So we can see in this top left corner that we are in progress aligning the plane. So for this operation, we need 3 points. Looks like we've got them. Now I have another dialog that's come up that shows me where all the points were measured and what was calculated more specifically. So here I can see, for example, that my measured rotation about the x-axis was about 0.67 degrees different from what I thought it probably would be when I defined the cycle. In this case, just to show how it works, I'm going to pretend that is out of tolerance. So I'll click cancel, and you can see the screen went away and the machine just went back to home. And I even got a message at the top that says program canceled, align plane operation rejected. So that's how it would work in that case. What I want to do next is step through that whole process chain, but go on the green path. So next I'm going to show you what happens if I select yes to everything. So here we're going to do a work offset measurement. So the machine's coming over to do our measurement. This is very much what we saw the first time, but what I'll do differently this time is I'll actually generate a report. So I'll show you how that works. And once this is done, if I like what I see, maybe I want to store it for reference later, I can click generate report and I'll go ahead and then click accept. And it's continuing on with my program. Here I've just located the Z0 of that transformed axis. And I can see my work offset measurement progress is about 40%. I'll hit accept and it carries on. Now we're looking for the rotation about the transform Z, and that was calculated with a small difference from the nominal. We'll hit accept again. Carrying on to the next process. Here we're looking for the center in the x-axis. So it did find the center. Everything looks good, so I hit accept. And now we continue on to find the center in our y-axis. And again, looks good, so I'm hitting accept. At this point, we're going to do a tool change and grab what we're going to use as a engraving tool, though it's pretty big in diameter. This next MMC dialog allows us to customize the engraving text. So here we can write CNC for you if we wish to, hit accept, and the machine's going to take off, engraving just what we told it to on our plane that we just identified in space. So that is how the cycle works. I'll show you what that custom log looks like. So here, this custom application that was created made this text file. It looks just like the screen that we saw. So we could save that if we wish to, and there's a date code at the end, so we know when that cycle took place. Now, the final thing is that since we have qualified the offset, we might want to come in and engrave something else, let's say. And what we could do is come back to our machine page, hit cycle start, and this time we'll select the engraving operation. In this case, it's coming straight to the truck, and we're going to put a different text in. So we'll do MMC demo. Now, if I try to keep putting in additional letters, it actually says entry length reached. So this field has been defined in the custom screen to only hold up to 8 characters. And that's necessary so that we don't have the text exceed the windshield of that truck. But now once I put that in, I can see the next operation right there, right on my inclined plane, centered, writing MMC demo as specified. Now, I think a lot of you are probably curious, how did this work? So you see what it did, but why did it do what it did? And we're going to dive into that next. So I'm going to carry on now with an analysis of the code. The first thing we're going to analyze is the MMC instruction itself. You can see this snippet here, which came from the NC programming manual. It tells us that the MMC dialog can be used to launch both Run MyScreens as well as user XML screens. There's going to be more information in the programming manual for Run MyScreens, and we'll look at that later. But for now, we're just looking up here at the NC programming manual. So I want to analyze all the different arguments to the MMC command and see what I selected as well as what they could have been. In the snippet here, we can see the order of all the blocks pertinent to the align plane dialog that we looked at moments ago. So here, first, I have a global GUD that's setting the progress bar variable to 20%. To create the timestamp, I run a cycle where I put all the times into global GUDs that can be accessed from the dialog. Then we put up a message command to let the operator know that the MMC dialog is active. And that's going to be important for a reason I'll show you in a moment. And then we have the call. Now, you might notice stop re after. For those of you who have experience programming with Siemens, you may know what that means. What that code does is it stops our look-ahead buffer. So if we don't stop the look-ahead buffer, what would actually happen is we would hit this message clear command, and it would happen as the dialog is active. So we would not even see the message coming up at all. It's important when we're using the MMC instruction to stop the look ahead so that we're not continuing to calculate in the part program, even while we're halting on the block that has the MMC on it. Next, we do have to turn off the MMC dialog. So we have the picture off command here. And then the last thing we do is we look at a return code and we decide whether or not we're going to continue, or in this case, if it's not 0, we'll go to our error handler. Now, when we look at the instructions, we can see that the address parameter was specified in our example as cycles. And if we look at the NC programming manual help, we can see that there are 3 permissible values for the address. They could be cycles, XML, or pop-up dialog. So maybe later on, we'll get into how to use other address parameters. But for now, we're going to focus on the cycles parameter. Next, we have our command. So in this case, we have both that command picture on as well as the command picture off that are possible when we're using the Run MyScreens user dialogs. To illustrate what this means, I'm going to come back to the actual presentation here and show you. So if I were to go ahead and run the program, we can see that the dialog's active, but where is it active in our application? If we hit menu select, you'll see all the vertical soft keys and the horizontal soft keys along the bottom, and you'll notice a brand new one that says cycles here. So probably a lot of you, if you're not already using the MMC instruction, haven't seen this. While my MMC dialog is up, if I wanted to, I can come back to the machine page. However, unless I had this message up here, I may not know that the dialog is still active. So that's why I put the message up. If I want to come back, then I just go to cycles and I can see it here. But that picture on command creates cycles. We're not going to clear it unless we also issue a picture off command. So when we're coming through our part program, all of that is structured properly, and we're always going to have a picture off to clear cycles. However, in the case of interrupting the program, we have to think about what to do to make a robust application. In my case, I chose to put the picture off command also in a reset program. I'll show you where that is now. So for those of you who are familiar, you can go to the NC data area, followed by cycles. And in my case, I put it in the manufacturer cycles folder. I created this prog event. And in here, we have the command MMC cycles picture off non-synchronous. Now, if I'm looking here at my soft keys, when I hit reset, the cycles key goes away. And that's because this prog event program just ran and cleared it. So even if we interrupt the program, we are able to clear that soft key properly and make sure that our behavior is as expected when working with these dialogues. This is one time to mention that though we're not changing the system software, if we're an end user of a SINUMERIK product, it might make sense to talk to the machine builder to make sure that we're not going to modify anything that they don't want us modifying. Many machine builders may also be using this special program event cycle that could run on different events, such as in this case, channel reset. So whatever we do want to make sure that we don't break anything. This is the I think only exception where we could be sharing space with a program that the machine builder is already using. So we definitely want to be careful on this one, but I did want to show you what I did to make sure that even in the case of reset, that cycles is cleared and things are working as we expect. So with that, we will continue on in our presentation to the next argument, which in this case is the file parameter. So here we've specified to go to the alignplane.com file. You can see in the NC programming manual the following snippet, and here all it really tells us is that when we're using Run MyScreens, the extension has to be .com. As we look one step further, I've put a snippet of where all those COM files are, and I'm going to come back to the real machine now so that we can see them. So in the setup area, we can go, instead of in the NC data area, we'll go to the system CF card. This is the proper path for systems that are running Operate from the CNC. If we're running from the PC, then there's going to be another link, oftentimes even on the desktop, to get to the user area and the OEM area. Now we'll look first at the user area. So it would be user SINUMERIK HMI, followed by PRJ, which I presume to mean project. And in here, you can see all the com files that define what the dialogues look like and what the significance of all of the variables are within those dialogues. Now, if you're an end user, you probably want to be putting your files in this area here just to separate them from the builder application. But if you're a builder, then you should feel comfortable to put the files instead in the OEM SINUMERIK HMI and then project folder here. As you can see, I don't have any in this case. One more area to be aware of while we're looking at the file structure is in the user area here, we can go to log. So this was user SINUMERIK HMI log and see an easy screen log file in TXT format. We're going to look at this in the last section of our webinar, the troubleshooting section. But while we're here, I wanted to point you to that file just so you know where it is when we get to it later on. All right, so now we're going to move on. Since we know about these files, we know where they live in the control memory. We'll look at the next argument. And the next argument is our mask. So every file could have one or more masks defined within it. And here we have the dialog set to mask underscore align plane. In our manual, again, it just really tells us that it has to be the dialog configured in the file. And here I pulled up a snippet of the actual alignplane.com file to show you where we call out in the mask definition the name of the dialog. This is actually going to be the next part of the presentation when we go through and start to understand how the masks are defined and how our COM file is structured. Remember, we're still on the NC programming area. So this may look confusing now, but hopefully it'll make a little more sense in a couple minutes. Before we get there, I do want to show you one more thing. So if we go to the memory of the control, we can actually dive in to user, SINUMERIK, HMI, and project, just like we did in the operate interface a moment ago. So this is useful for me. What I've done is I've taken this path here and I've opened it as a workspace within Notepad++, which is my preferred text editor for code. So in this way, I can actually have all of my files, all these COM files open as a workspace, and I can edit them as I like here. Now I have the align plane open, and you can see in the COM file that the dialog name is defined right here, mask underscore align plane. And that's the one that we referenced in the MMC call. So we're going to move forward back to our presentation and look at the last parameter. The last parameter is called the quit parameter. So in our case, we specified it as S. There's 3 permissible values for the quit parameter, which is the acknowledgement type. It could be no acknowledgement, asynchronous acknowledgement, or synchronous acknowledgement. In the case of no acknowledgement, the MMC command is just going to proceed after it's executed. We won't have feedback if it was executed successfully or not. This is what I think we're going to use a lot of times in the picture off command. A is asynchronous, so this is similar, but we'll have feedback if the command was executed properly. And the final one is called synchronous acknowledgement. I chose this one because I wanted it so that as soon as I pushed the green button, the machine continued with the part program. And that may not be how you want it in your custom application. In the standard Siemens cycles, for example, we do invoke the MMC instruction if called for in the cycle 150 associated with the measuring cycles. And in that case, we would have a cycle start to clear the MMC dialog rather than hitting the button within the dialog. So it's up to you how you want to do it. This is just how that example was configured. Next, now that we've gone through all the arguments to the MMC instruction, I want to take a look at the supporting documentation for the actual development of our .com files. And here, what we can reference is the SINUMERIK Integrate Run MyScreens manual. Um, in this case, I've highlighted the full manual because it really is important to go through a lot of these sections and get a good understanding of what's available so that you know how you might be able to implement it to meet your application need. In this webinar, we're not going to get a chance to go over everything, but instead we're going to look at just some of the sections that were used to create the application we just saw. In the future, we'll have additional training opportunities for anybody interested who wants to learn more about the MMC instruction, as well as developing screens with Run My Screens. So here I'm talking about the extended configuration syntax. So if we remember from the, I think, third or fourth slide, I talked about the compatibility with the extended configuration syntax, and that is as of CNC and Operate software 4.7. Here you can see in our mass definition that we have identifiers for each argument. And so instead of relying on the order that the arguments appear in our mask, instead they're going to be called out and identified by these. And you don't have to use every single argument. You can just pick the ones that you want. In the example, I've only used the ones that you see highlighted here. And now I'm going to show you the significance of all those in our mask definition. First, I use HD to create the text that's in the upper left corner where you see it says in process measurement result. Next, I used the HLP parameter to identify which image we want to be part of the mask. And you can pick really any image that you like to and place it wherever you like to. In my case, I picked the standard align plane icon. And in memory, you can see that it exists on the Siemens area. I'm going to show you where those are just so that it's familiar. So we're still in the same area. We're still in the system CF card. If we go down and look at the Siemens area, you're going to see that we have an HMI folder, and we have icons, and then we have a bunch of subfolders pertinent to the resolution of your system. It's important to know that all of this is based on pixels. So we're going to have to know what the resolution is. We can do some amount of math, perhaps, to move things around and scale them. But my particular application was created for the resolution that you're looking at here. And the icons in this folder would all be pertinent. So you can look down here and you could decide to use any of these if you wish to, if they're going to meet your need. But if they don't, you can also define your own. So what I would do is if I was an OEM, I'd go into the OEM HMI area and go down to ICO and then here. And you can see some of the custom ones that I created. So for example, I made this select image so that you knew that it was a touch button and had to touch the screen. So you can use whatever you want. You just have to place it in the right folder. So moving forward, we have another identifier in our mask callout for the picture offset in X. We have a picture offset in Y. And then the last one is our mask background color. And this is the hex value. You can see the color picker wheel that I brought up there. And you'll notice that the color here actually matches the background. You could pick whichever color you like. Personally, I like something that stands out so that the operator knows that intervention is required versus the standard gray. Moving forward, I want to look now at the extended configuration syntax for variables. Within the dialogues, there are also a lot of variables that were displayed that you just saw. Again, with this extended configuration syntax, we don't have to select every argument. We can pick just the ones that we'd like. And in this case, the highlighted ones are used. Here, we're going to look next at the significance again of all of them. The variable that I'm highlighting is on our aligned plane com file, measured rotation about x. This was defined as variable 3. It could have been given a more significant name. This was one that I selected as the developer of the file. The type that was displayed was specified as R4, which signifies real, and the 4 is the number of digits after the decimal place. I could have picked an integer, a string, a character, a bool, or other types. Next, I have the WR parameter, where WR equals 1 was specified, indicating that in this case, we're only going to read the parameter, and we're not going to allow input from the operator. The next thing is the ST parameter. So here we've pulled up a screenshot of the actual mask you were just looking at, and you can see the text measured rotation about x-axis is specified here. The next thing is the actual system variable tied to the display. In this case, I picked underscore OVR array index 3. And that might not mean a lot to everybody, but this is the results register from our measurement function. I want to show everybody how I found it real quick. So here, if I go over to my measurement cycles manual, you can see this is the actual cycle that was called. This is our 3D aligned plane cycle. And if you scroll down, you'll see the measuring principle. So these were the actual points that we measured. But if you scroll down even further, what you're going to see is that we actually have a list of result parameters. So here in our manual, it tells us the significance of all of these global system parameters. And in this case, OVR4 indicates the angle actual value between the workpiece surface and first axis in the plane of the active work coordinate system. So for the strategy I selected, this happened to be the measured rotation about x. So if you want to dive into that manual yourself, you can find the significance of really every variable used in our measuring cycles. Next, we'll look at the unit text. Here is just a text field. I put in degrees. We are able to specify an offset in pixels between our unit text and the variable display, in this case 15 pixels. We have an offset of our short text from the left in X, which is 40 pixels, offset in Y, a width. We have next specification of where our actual variable appears. Here we have X, Y, and again the width. So moving on to the next part that I want to look through of the code, we're going to talk about the soft keys. We have a lot of different types of soft keys. In this case, we're talking about our vertical soft keys and horizontal soft keys, and we have 8 of each of those. In this application, I used vertical soft key 2 to have an event tied to it, which would generate a report. Then I also used vertical soft key 7 and vertical soft key 8 to either reject or accept the results. We can see in the manual here that there's a lot more you could do if that sort of call out didn't meet your application requirement. You could decide to add a picture, for example, to the soft key, and you can even decide an access level. So maybe the user isn't allowed to do a report, but somebody of a higher access level is allowed to generate a report, for example. A lot of the soft keys are pre-developed. I didn't want to make my job harder, so I wasn't going to create more symbols and more pictures than I needed. In this case, the reject, the cancel, and the accept buttons were fine for me, so that's what I selected. And in this snippet, you're looking at a HMI skin similar to what we have on the 840 and probably on the 828s. The buttons are a little bit different on the SINUMERIK one, but they're still there and supported with the identifiers that you see on the left. Now, I want to talk about the actual methods and functions that are configured in the COM file. We talked about how we define the file. We talked about the variables within it, but what do we do once we're inside it? We have various methods. The first one I'll talk about is the press method. So this is going to be called whenever a soft key is pushed or a number of other keys on our display. So we have the recall, the enter, the toggle, as well as page up, page down, and so forth. You can see here in the actual snippet of code from our line plain function that when vertical soft key 7 is pushed, that I'm calling a function. So here I'm writing to the global user defined parameter MMC return and writing a 1. If I hit accept, I'm writing a 0. If I hit recall, I'm writing a 7. Now, the recall event, actually, you can see right in here, that's inside my press. That's what makes it so that this event is associated with the recall key. I'll show this to everybody because you might not be familiar. So here on our display, if I were to say run it again, here I'll reset the workpiece and just hit cycle start. And when this time, maybe we'll go straight to engraving. If I were to hit the recall key, which is this little key, I wanted to have a special event. And to do that, that's why I used the press method with recall. So here we canceled the program because recall was pressed. That's the example there. So moving on, I wanted to talk about a function. This function is the write NC or PLC variable function. And that's the one you can see here. And we can move on in a bit to troubleshooting, but I want to take another look a little bit deeper into our application at some of the features and functions that I didn't get to in the presentation. So the first one that I want to look at is maybe I'll just show you where the GUD parameters are defined. So there I have an NC data and in definitions, a mgud file that I created. And these are the variables that are used in this application that you're looking at now. One of the things to consider is that the dialogues do, to my knowledge, work best with global user-defined parameters or system parameters. If we're defining our parameters locally in our program, I think we may encounter some challenges. So for that reason, I put some of the parameters here. The next thing I wanted to show you is the selection button. So when we run the program, actually I can't because there's an alarm, and that's by design. That was because I hit the recall key. When I run the program, we can see that this dialog comes up and I have those two options that are buttons, but you may wonder how I configure the buttons. So to configure the buttons, what we'll do is look at the code. Here, we have to look at our selection program, and you can see that I've defined the buttons in this way. I didn't use the extended configuration syntax, so rather than having identifiers, we have to rely on the position of all of the arguments separated by forward slashes. So in this case, we have just the button type defined there, and then some parameters about the button size. But we don't have a lot about the button, so we have to actually go down, and it is inside this load event that typically is used for defining different graphics, that all the button properties are written. In this case, I only used 5 button properties. So I have one for the actual text that appears on the button style, if it's 3D or not, the button color, and then the button color when it's pressed. For anybody that wants to learn more about buttons, then I suggest going to the Run MyScreens manual. Here, it's chapter 9.6, and you can find out a whole lot more about how to make buttons. You can also find out more parameters. So I used, as we just saw, 5 parameters, but you could actually use, I'm guessing, 20 or so. I didn't count it, so hold me accountable. But there's a whole lot of different parameters here that you can use to meet your application requirement. So that's just a little bit about buttons there. What I want to look at next is how the program's structured just a little deeper. So if we go into the program manager, we can pull up our custom program. and look at, for example, a line plane. And we see here that after the cycle ends, that if my return code isn't 0, we're going to go to cancel. In the error handler, we will see that I'm first going home. So I first go home, put up a message that the program was canceled, and then I set an alarm based on the value of the return parameter. Some of you may be familiar with cycle alarms, but if you're not, I'll walk you through how to get there. You'll go to Setup HMI Alarm Texts, and then pick the manufacturer's cycle alarm texts file. So in here, you can see the messages that I configured to be associated with each of the alarms. This is another area that you might want to be a little careful in if you're using a machine that was already configured by an OEM. They may have certain alarm texts that are already implemented, so you would have to pick a number that they weren't already using, for example. All right, so I'm going to move forward now and talk a little bit about the generate code function. One thing that we did, if you recall, is that we hit generate code and we saw that this was populated. And I'm actually going and talking about the function on accident rather than the description that said generate report. So the functions are all going to be listed here for us in our Run MyScreens manual. These are programming commands, and we have a number of different commands. First, simple math operators that you can see here. Then we have our methods. We talked about the methods a little bit. Some of the methods are going to be our press method that we talked about. And then there's different ones as well. I think exit is one of our methods. And finally, functions. So in the functions area, when we scroll down far enough, we'll see this one here, generate code. This is what I selected to create the text file, but it might not be what you want. Another thing you can do is write to a file. So you do have file access if you want to use that method instead. I'm going to look at the actual code in a minute, but I wanted to show you the manual first. So if I go over here to my Notepad++ and look at any of my measuring dialogues, we can see as we scroll down that there is, let's see, this is a selection dialog. So we have to pick a measuring dialog. We can see from the top that first I define my mask, then I set up some display variables, then I define helper variables. So the helper variables are really just like local variables that I could use in this .com file for whatever purpose I want. And I do use these later down when we come to the press method for the generate reports button. So we're going to get back to this function in a bit, but first we'll look at the press method. So here I'm setting my helper variables to all of these values of my GUDs, and then I'm creating the postfix with the date. In my case, just to show if and maybe else if structure, I show what happens and how you can do that to put in a month rather than just a number. And then I build up my file name in this helper variable here. You can see all these little signs concatenating each of our local variables together and then appending it with the text extension. The code that makes everything happen here is GC. Here, I'm going to run my results1 function, and I'm going to name it what was specified in my helper variable. And then in my results1 function, we look up and we can see exactly the code that we looked at moments ago. Now, one thing that's interesting once we get into the easy screen log is that the CNC is going to recognize this as code. It might think that it's invalid. If you are still in the process of debugging and you don't want a message, it would be prudent to do it like this so that it comments it out in your text file. So that's just something to know about there. Now I want to continue on to the last demonstration I have with the real machine. So I've shown how this application you're looking at was created, but I want to show you what you get standard right out of the box. I'm going to run this program, MMC default, instead. So here, before I run it, I'm going to show you how it's configured. I put in the cycle 150 prior to my align plane cycle, and then I put 160 after. If we want to, we can find out exactly how these cycles work. They're going to be in our measuring cycles manual, but we could also just hit over to see the cycle mask, and you'll understand that you can have this display active or cleared rather with NC start, or it could be automatically cleared after 8 seconds, for example. You can decide to have a log or not have a log, and then you can specify formats of the report. You can specify the directory, so where the report is generated and the report's name. In this case, I used mesh1 default. And then in my case, this cycle 160, this actually generates the report. So this just configures the report and tells us that when we run the align plane cycle, we should activate a custom dialog with MMC. And then the cycle 160 is going to generate the report for us. So let's see what this looks like. If I execute it and run it, I can't do everything in my application requirement, because if I really do want to engrave custom text, then maybe a MMC dialog is the right way to go, a customized one. But if all I want to do is look at the measuring results and I want to be able to create a text file, I can do that right out of the box with these default functions without doing any customization of the COM files. So here you can see that same difference that we looked at before, 0.67 degrees, minus 0.76 degrees. And if everything looks good, I can go ahead and hit cycle start. Now, in this case, because we don't have the same structure where we have the return variables, I can't automatically retract, but I certainly could hit reset and then manually move the machine. I still have the display, and in this case, a log file is just generated with the cycle 160. And these are set up for all the measuring cycles that were a part of our process flow. So I'm going to go ahead and interrupt the program now, just for the sake of time, and I will show you what was generated. So these are the default files. Some of you may be familiar with them, but if they met your requirement, excellent. If they didn't, then now you have an idea of how to create your own. Anyway, we're going to jump back to our presentation here and proceed with troubleshooting. One thing that's available for you to use is the EasyScreen_log txt file. I find this file to be really useful, and I do recommend that you use it as well if you get into developing these screens. What you can see in this example below is I purposely loaded a graphic element, a rectangle, and I didn't put a parenthesis at the end. Well, you can see in my log file here that it gives an error that I have a parenthesis missing. But not only that, there's an extension that even tells me it's on row 35, which if you look up here, you can tell it was row 35, and the command. So this, in this case, was really helpful. So I actually did make this mistake as I was doing the application, and I found out how to fix it. The EasyScreen log file is not always going to be this helpful, but it's definitely a resource that you want to keep in mind when things don't behave as expected to take a look at. Now, there's one more function that can be really helpful, and that's called the debug function. What you do with this function is really create a custom printed line to the EasyScreen log file. I'll show you how this works in a second, but I do want to mention that this debug file is something that we probably don't want to have in finished applications. Instead, we want to use it in the draft phase, only because it could slow down processing. Anytime we're doing a write function, it's going to take a little bit extra resource. In this case, what I wanted to do is create an entry in my EasyScreen log that indicated that the engraving was accepted and what the text was that was going to be engraved. I added that to the press method, and then after I put in this and I ran the code, you can see in my easy screen log txt file that a line was appended indicating that the engraving was accepted and the text was equal to that variable that we specified on the screen. Finally, we get to the end, which is Run MyScreens licensing. Out of the box, I think you're going to find that many of your application requirements can be met with 5 screens or less. However, if you end up with more than 5 dialogues, the application you saw moments ago had 7, you might see this message when you call up the 6th dialogue, so the one after 5. Yeah, that would say the option to display more than 5 screen forms has not been set. If you see that, the solution is to enable the P64 option. And so you can see it here where it's set. I would say that, like all other options or most other options from Siemens, uh, before you go ahead and license it and buy it, you can activate a test license to see if it's going to meet your application. So if you're happy with it and you know it's going to do what you need, at that point, you can contact your preferred Siemens sales channel and get the option. But in truth, again, the application you just saw had 7 screens. Could I have made it with many fewer screens? Absolutely. These are really dynamic. It may have been harder to follow the application logic because I'd have to use the same variables for multiple purposes, but absolutely it could be done with fewer dialogues. Now, if you do find that you want to have that option, then here are the 2 part numbers for you. If you have an 828 or an 840, then it's going to be the article number here that you see to the right with 9th character equal to A. If it's a SINUMERIK 1, it's pretty much the same number. The only difference is that that 9th character changes to a B. The short option code is P64. Now that completes the content that was prepared for all of you today. I'm Brian Baumgartner. I'm a technology systems engineer with Siemens. It's been my pleasure to give this presentation to you, and I hope that you found it beneficial. I look forward to answering any questions that you may have next.
Yeah, thank you, Brian. Amazing job. So we have some questions coming in the chat. One of them is the OEM using up some of the 5 easy screens, or is this just for end users? And if they have, how can they see how many they have?
That's a great question. I think, unfortunately, I don't have the answer with 100% certainty to that. I know that when I created this application, I could have more than 6 screens, more than 5 screens defined. And it was only when I went to call the next screen that I had to have that option licensed. So I think there's a possibility that they could have those screens and that they won't necessarily eat it up. But I would want to mention that I think many applications out there are already going to have the P64 license on them because many OEMs do create their own custom interfaces for service purposes, for setup purposes, and it's a very widely used option already. So a lot of you are going to find that the screen limitation isn't something you're going to hit because the machine already came with it. That's how it responds. But if an absolute answer needs to be obtained for that question, do feel free. You see my email here on my contact card. Just send me an email and I will take a look.
Yeah, there's a couple more that came through. Is there a minimum CNC software version for this?
So the main design consideration is that you have to have SINUMERIK Operate. Almost all SINUMERIK applications that I've seen in real life do have that. Some caveats might be if you've created your own screens in .NET and for some reason they decided not to use the Operate HMI that we have in Sinutrain that you can see, as well as in Create My Virtual Machine, which we were just looking at. But as long as you have Operate, I'd say there's close to 100% chance that it's going to work. Nothing's perfect, but it's close to. In the first or second slide, I went through the compatibility, And how I did that is I went through all the programming manuals that we have at Siemens, and I looked all the way back to about 2008. And even from that manual, which corresponds with the rollout of the SINUMERIK 840D solution line, we did have support for the MMC instruction there. One of the differences is that that extended configuration syntax I talked about, that's only supported with 4.7 and greater for the 840s and the 828s. And I think it's just a whole lot easier to program that way, personally. That's what this demonstration was prepared for. So this demonstration is only going to work with that software. If you did find that your software is older than that, but you still want to use Easy Screens, we do have a lot of supporting documentation to assist you in that effort. And feel free to schedule a virtual product expert session, um, and we can look at it together to figure out what you need to get.
A few more coming in here. Says, do you have any ID IDE for programming where I can check the correct syntax and debug code? I think they're trying to ask, like, is there
It's a good question.
is there a way to debug before you put it on the control?
Okay, that's a good way to qualify it, Dan. Thank you. So the actual question was asking, was there a development environment with the debugger? And I'm not aware of one. So the way that I did it is I opened it in our Notepad++, the open source, I guess, software as a workspace, and then I can work on it there. I have a custom language, so that way it'll identify my defined commands, for example, is blue and my comments is gray. I think that's the easiest way to work with it. But this software, it's not like our PLC software that has usually the TIA portal development tool. Instead, one of the beauties of it is that there's no prerequisites to do it. You can just get started with a text file. Now, to add on what Dan had mentioned just now, is they're really looking for a way to test it without using the real machine. And I think I had a really good experience using my virtual machine, as I just showed you. So you can do exactly what I did. You can take a backup of a real machine, and then you can load that into my virtual machine, make a digital twin, and have that zero risk environment to work in and check all the behavior before it goes out, onto the real machine. And that log file is the best that I know of as far as syntax checking, but it really isn't that bad. In the example I showed you, it told me about the missing parenthesis. There are a lot more messages that you'll see if you have improper syntax.
And then it looks like, can this work on an 810D?
My understanding is no. My understanding is not for 810D. But the question is,
where would someone go to learn more about this?
I think one of the good places to go is actually something that Dan promoted at the beginning. So he told everybody about number one, our virtual product expert program. So that's going to be usa.siemens.com/VPE, and that'll get you right to the form so you can request a live meeting. But we also have a new channel. So we have the Mr. CNC Insights channel now that has more information about our kind of commissioning related topics, service related topics. You could go there. I haven't put content up, but I hope to have more. Certainly, this webinar will be there. And that's where to go. But other than that, I personally learned very well from manuals, and I think we have great support in that way. This is a wonderful manual. This is the Run My Screens manual. It shows you all of the different functions, like I was showing, all the different commands and methods. We have the NC programming manual. So in here, this is actually how we interactively call the window from the part program. And you can step through this as well. So that's what I would say is what you've got available to you.
So I don't have a question on the last one, but I heard some exciting news about this topic coming up. Is there something in the future that might come up with this MMC command and commands like this?
Right. So I don't know exactly the format that we're going to roll it out in, but between all of us and our technology application team, we understand there's a market need for just education on this topic because it could benefit a lot of processes. Um, we haven't yet created the program, but soon we will add this either to an existing training program that we have, or maybe create a whole new class that you can sign up for. So you can definitely look out for that coming in the near future. With the development of this application, we've already got a base to be used for training, and yeah, that's definitely something I'm looking forward to in the near future.
Yep, I think that's oh wait, we got two more questions that just popped through. Hold on one second. Uh ch- yep, we got through that. No, looks good. Yeah, there's a couple quick people asked a little bit about standard messaging. I have your question and I'll email you personally. A couple people asked, we kind of went a little bit deeper into these types of MMC command, but there is a way to make a standard message pop up in the middle of the screen.
Oh, sure. Yeah, there is. So one way to do that would be like this. So if we went into our setup area and then HMI, go to our alarm texts, where you saw all of these messages were configured, we could create a new one like this and call it my custom pop-up. Make it a pop-up by hitting yes, say okay. Now it's not going to be active until we do an HMI restart, but after we do an HMI restart, when we come into the machine area MDA, all we would have to do is hit set AL, and this was 65007, I believe. Something just like that could be used to create this custom pop-up. 008
Perfect.
rather. Yeah. So that one's not too bad. Like that.
I think that's it for, oh wait, one more question. Can you send us your custom Notepad++ language for 840D? Can you email it to me as well?
I don't see a problem with that. Sure.
Yeah. Yeah. All right. Well, that is all we have for this webinar. I appreciate everyone joining us. And thank you, Brian, for coming in and being a guest speaker on the MMC command.
Absolutely. Thank you, Dan, for giving me the opportunity.
All right. We'll see everyone later.